Is the solution to the circular motion conical pendulum question. We've done the theory of this already, but here's a question directly related to it. So a ball attached to the end of a long string is made to rotate in a horizontal circular path at a constant speed. The forces acting on the ball are its weight W and the tension T in the string. And here you have the free body force diagram showing the weight acting down, the tension acting at an angle theta to the vertical. With reference to the free body force diagram, explain how it is possible for the ball to move at a constant speed and yet still be accelerating. Note, with reference to the free body force diagram. So we've got to talk about this in some way. It's not the standard, no reference to the question kind of answer. So we have the standard text for that, which is the direction is changing of the ball, I suppose I should say. So the velocity of the ball is changing since velocity is a vector. So there is a resultant force. Which is required for the acceleration. But then that's your standard answer. But with reference to the free body force diagram, you're going to say that T sine theta is your centripetal force. It is the horizontal component of T. You might also, just for completeness, say that T cos theta is mg. But that's where your 4 marks come from. There's going to be 1 mark for that. There's going to be a mark for that, a mark for that, and then a mark for observing that as the velocity is changing, there has to be an acceleration, and therefore there has to be a resultant force to cause that acceleration by Newton's second law.